Okay, checking audio. 1, 2, 3. All right, I think we're live and moving well. So, welcome to the stream of the Discourager of Hesitancy. Today, we are doing game development with no game engine. And we're kind of, if all goes well, today will be the last day of development on Word Sleuth. We can talk about what that means here in a minute. But last week, we compressed our executable size to 25% of its original size. And then we did that by shrinking our audio by 1/4 and our image data by more than 1/4. So, hey, Suki, welcome back. How was your weekend? I realized I did not do a good job recording our improvements in the image data side, but we're going to get on some front end. Okay, all right. Good. Ooh. What do you use for your front end? Or is it for your game you were doing? I don't remember. SDL? I don't remember. My game. Yep. I don't remember what you were using for your front end. JSON. GWS. That was it. Your own scripting language. Nice. Are you embedding GWS text inside the JSON as a means of delivery to your backend? Or are your GWS scripts completely separate from the JSON? Okay. So JSON points to a file, basically. Okay. Cool. One thing we did really badly last week is, let's hear, not last week, but this. I should have this data up here for images, which we did not do. Image data. This, we need to go get some new info somewhere. The runtime usage needs to get replaced. Yeah, so we kind of need to check out an old version and run the numbers. I do something like link res script. Yeah, x.gws. I think my GUI library is pretty much complete and solid. Nice. It's 2D focused, right? You've got your World War I regions being defined and displayed. Right. Cool. Sounds like good progress over the weekend. Okay, so we need to check out an old version just to do the comparison properly. Add a save manager. Nice. Yeah. Running good saves is a good thing to have. Okay. So let's go grab those numbers. Where are we? PWD. This is VV, which we're going to leave. Oh, let's see. let's just get a new process up here, new Emacs buffer. A good save manager can be a little bit on the complicated side, but usually not too bad. Okay, and then word sleuth easy doc journal. All right. So we're gonna get these numbers real quick. So we have a proper report. We add everything we get, commit. We won't edit anything, we'll just commit it. Okay. So we go back to Monday. Let's go to what we left off with on Monday. That's the 16th. Yeah, that's fine. We're going to do a git checkout of this. A list box thing. Yep. Are you using like IM-GUI or something? I don't remember what you're using for your front end, for your GUI layer. Doing it all from scratch. My own. Cool. Very good. Okay, we gotta do an actual rebuild here. So I think this is what we want. So we're cleaning everything, including our resources. Fully rebuilding our tools up. And our tools are getting run. Asset pipelines, so our images are not being compressed, they're just being embedded. We need to check out Wednesday's first, or Tuesday's last stream, Monday's first stream. I have to look at the logs. At the moment, there are only frames, image box, labels, and buttons. Yep. That sounds like the start. Now you need a list box thing, as you call it. Okay, so this is not the one we want. We're just gonna kill this compilation. Maybe this one. Oh, let's see here. don't think we really care about any of these changes, so we can do, what's it like? It restore force head. Let's see. I'll have to create custom views for that. Yep. Then complexify even more. My GUI lib. Yep. Just because of dynamic stuff. Yep. GUI libs can get very complicated. Very, very complicated. So let's take this. Do what I wanted. And then do this. Okay. Check out this file, maybe. Let's see if this outputs what we want. Mm-hmm. This is what we're looking for. Let's put this in a scratch buffer for now. Wait for the compilation to finish, and then we run it. Image warehouse was this. Let me just wait for the build to finish. It's gonna be easy for the moment to make mine like Minecraft did in its early days. 5 saves. Yep, it's always easier. Yep, that's correct. Don't design yourself into a pigeonhole, but you don't have to design the final product the first time around either. If you can handle 5, you can bump that up to do anything. So a 5 save prototype is fine. In fact, like Ori and the Blind Forest did that too. It's got like 4 save slots or something. You have to delete a game if you want to create a new one. I don't know that number. Yep, a working prototype is a very valuable thing. Okay, we just hope this runs and we get this information. So these are the 3 pieces of information we wanted to capture. And quit. Reset -f embed. Okay, so I don't remember the command. Reset hard. All right, fine. Check out the master branch. Okay, I probably got to go return this phone call. Hold on a minute. Okay, I'm back. Sorry about that. I'm trying to get an electrician out to look at some work, but it's been tough to get people scheduled this time of year for some reason. I think I've got it for tomorrow, so we're good. Okay, what was I doing? I was copying things out of here. Yeah. So before we optimize things, this is what we were looking at. So when we embedded the file, we were reading in 7.5 megabytes of PNG compressed data, which leaves us with 63 megabytes of raw image data. So 4 bytes per pixel, RGBA channels, 8 bits each. And we're not compressing it at this point in our checkout. So 100% of our original size is what we're compressed to. And our runtime confirms that we're running about 63 megabytes per image, so they both agree at embed time, at image asset pipeline time, and otherwise. Then we're going to check out master. I'm going to rerun the whole build, and it should be much quicker now. 2 saves right now is fine. Yep. 2 is, as long as you can do more than 1, you've already not pigeonholed yourself too much. Okay. We are close. So what we've done is we've taken our PNG image data, we've expanded it out to completely raw image data, uncompressed. We've now compressed it on the embed side of it, but on the usage side, so inside the game itself, it's not doing the right thing yet, which we will show you shortly here. Okay. We go into compilation and we look at our image data output. Oh, we did not write down those numbers correctly in our code. So let's embed PNGs. Oh, tools. Embed PNGs is, let's see, we're looking at image data, total image size, except that we do this, which is wrong. There we go. Let's rebuild this real quick. Let's see here. Tools bin /embed PNGs. Come back up. Is it 2+, you avoid making the mistake of only saving in a way that would require a rewrite of the saving system. Yep. 2 is like the minimum requirement. There we go. There's the 63 megabytes we knew was our input. When we embed, we're now getting compression down to 14% of our original image size. So we are slightly larger than PNG, but we're not dealing with the complexities of PNG. It's a very simple format. And we're compressing from 63 down to 9 megabytes. So we're at 14% of what we were doing before. So that's nice. Then get our image warehouse, and now it is very respectable. Our code size. We went from 2.37 million lines of code down to 350-ish thousand lines of code. So that's awesome. And then we just need runtime. And this is what's wrong with our images. Are you ready? We're going to do this. Our textures are not going to look right at all because we're handing it garbage data. We're saying, here's an image, here's an address. and it's just reading out memory. It doesn't know anything about that memory. It thinks it's RGBA encoded 4 bytes per pixel, but it's QOI data. So we have to decode that to get this to work. But we did get the piece of information I want, which is that. Which does agree, our 9.254 megabytes. We're averaging half a megabyte per file. So very good. So now we need to fix this visual. It's got just garbage values in there. I'm actually surprised it doesn't crash, but that's fine. So let's quit out of there. Let's save this. So we didn't add any new work over the weekend, so we're just going to keep this where it is. Just with our numbers added in. I have about 2,700 lines of code, including JSON scripts. Okay. Nice, nice. That's not a very big project yet. It's getting there. I think I'm up around 30,000 lines of code for this project. But only 4 dependencies, so you always have to write more that way. Wrote my own text renderer, buttons, labels, all that stuff. Fun times. Okay, so now we're ready to proceed with today's tasks. We're going to put QOI decoding on our texture side. And then we're going to take one of our last things out of our to-do list. Stream tasks, size optimization. We've basically got this done. We're ignoring that for now. This one. This is the big one. For today. Everything else, we're not going to do. This is done. Basically, this is done. And we're going to move this all down to here. So I have some off-stream tasks. And then, yeah, I'm basically done programming today if all goes well. So things I have left to do. Add some words to a library of lookup words. Not a big deal. Add some animations, that's art, and then just updating the art, which is not code. If I get any more art, I'll put it in, but again, there's no code involved. It's just putting the art in, and same with songs. So there's no more coding done. If we're good, we'll be done with this streaming series today. This is our list to do. That's it. Let's just say the map is 1/3 done. It has 1,800 lines of JSON. Yeah. So raw map data, I would not usually count as part of my code base, but in your case, your JSON is pretty expressive, so maybe it's okay to count it in your code base. JSON is very, very line heavy though, if it's being formatted normally. 1,200, yeah. C Films, I'm doing good. How are you doing? I think we're on the last day of coding on this game. Everything else is integrating art, which is not interesting, and like the website and the trailer, which we're not going to do on stream. So I think we're this close to just being done with the game. We just have to get it the rest of the way to Steam. So we're in a really good shape for this week. Which is good because it's Christmas, right? And so I'm not going to stream tomorrow, and I'm not going to stream Wednesday. Never forget that I count only parts that are hand-coded. Yeah, no, I don't count. So, for example, my millions of lines of code that I was talking about here, like these ones, I've never counted them towards my line count. This is generated data from a binary source. So I never compute this in my line count, other than compile times, right? So I want to shrink it so my compile times get faster, but I don't count this towards the reported lines of code that I write. I agree. Yep. Map data is hand coded. Okay, all right. If it's hand coded, it's legit then. Although, couldn't you just get some GIS data and import it? Okay. Notes. Okay, so if we go to our run, everything is messed up, including this logo. So let's fix that logo first. I think that'll be the easiest one to do. So in main window, or window, let's see here, icon. That might be part of application. Set icon. Okay. So we get the pixels, the width, and the height. And this is not quite right. Perfect. All right. So what we got to do here is this is now returning QOI encoded data. So what I need to do is let's look up image warehouse.h. Get data, returns a constant char star. Okay. QOI payload equals this. QOI size equals image warehouse get size of that same asset. Now, window.hpp we're going to include our QOI decode our QOI data QOI payload image width image height and the size, which is probably not the best order to put these in, but whatever. Decode is going to return a character star. We need to cast it. If this is all correct, then the logo in the corner of our game should work without affecting anything else. So we get our width and our height, we get our payload and our size, then we decode it and shove it into image pixels, then we can set our icon. So let's try it. Ready? -k debug. Okay, now it creates JSON automatically. Now it creates JSON files for save data. Yep. QOI, there it is. There it is. Decode. I'm going to ignore that for now. Maybe I do a little bit of cleanup around QOI. We run it. And our logo in the corner, which you probably can't see, is displaying correctly. So I think we're done with that. Do we just do our QOI cleanup right now? All right. If we're going to read something, we should do uint 8t. File name, width, height, size. QOI size, width and the height. We encode. If I put our raw data and our size next to each other, same thing here. Our raw data should always be uint. Let's see, anything else? Const char star QOI, const uint 8t. That's going to change a bunch of stuff. QOI.cpp. I think we can just get rid of this. I know the trick now. I think we can get rid of both of these. And restructure the thing down below. Log, whatever, read. Okay, so we read uint 8t. Uint 32t. Uint 32t. And we want size. Oops. And then width and height. Uint 8. Result equals new uint 8. Okay. The game looks very normal. Yeah, it's just fun going through the stages of coding, right? With height done. If it fails, blah blah blah. Okay, right. Uint 8. Then size that with height. All right, let's see here. It's gonna take a little work to get that all come back to work looking the way it should. Encode, we want to write out the size, so that's fine. That is U8, good. Blah, blah, blah. Okay, return. Oh, we don't want to pass that at all, so that's good. Decode, uint 8. uint8. We've been putting size next to our payloads now. uint8, uint8. There we go. Think. Okay. We were asking, can diff right here. Okay. This is where things got a little interesting for us, and we are going to simplify while we run a couple of tests. So otherwise, basically going to get this information, but we're going to be a little bit more careful about how we treat it. In C, it's an interesting thing. It will do the wrapping for us if we take the difference between two unsigned and shove it into a variable that is signed of the same size. So the fact that I was using int here was preventing the wrapping calculation from happening. So now we can check the wrapping easily. Right there. But we also want these two to do the same thing. Int 8. 8. Good. Now, if -2 less than equal to dr and dr less than equal to less than equal to 1, and less than equal to dg and dg less than or equal to 1, and -2 less than equal to db. So these are the changes in colors. 1. This is the case. Then we can put that in with an offset. Easy. So that cleans that up. And Luma. We deleted it. Why did we delete it? Green was between -32 and 31. All right. Let me see here. So the red channel between -32 and 31, yeah. Else if -32 less than equal to change in green, and change in green is less than equal to 31, and -8 less than equal to change in red, and change in red less than equal to 7, and in red, change in blue. Those are all the case. And we do this, which is change in green plus 32. Oh, which we'd already had that offset factored in. And this one. Oh, so I guess that's it. Boom. Else if current.alpha equals previous.alpha, then we do this. Otherwise, we do something else. Oh, we didn't break anything. Okay, otherwise, and this is another otherwise, which is easier to figure out. This is if they are equal, therefore put that red, green, blue. Put alpha. If they, oh, we don't need alpha. We just need, okay, let's see. These. FE, if they are not equal, which they are not, put that red, green, blue, and that should fix it. So that'll simplify our code quite a bit. Encode. I think we're good. We had a way to test this somewhere. Where did I put that? Those tests will be a little bit out of date with what we've got now. Okay, if we were going to compile, build a test, QOI, I think that'll do it. Biggest new declaration of decode. Oh, right. QOI size, width, height. Okay. Comparisons, offset. I think my game has extensive logging. Yep. You should have lots and lots of logging and a way to turn it off or turn it down. During development, you always want to log more stuff. Then as you get closer and closer to shipping, you want to start turning that down to what you need to diagnose problems. Stuff, blah, blah, blah. Oh, not too shabby. Read int 8. Raw decode. Okay, so our right bitmap okay, getting close. Encode. There's our data, the size, width, and our height. Encode. Raw size, width, height. All on the side of things. Image data. QOI size, width, and height. Complete. Okay, maybe. It's are linked there, so that should not be a problem. Hmm. Unsigned. How does that unbind? Encode. Unsigned, unsigned, unsigned. uint 8 raw. There we go. There we go. So we should be able to /source builds debug test. Oh no. Tools bin run it. Decode question mark. It did fail. What does our test even look like? Okay, well, we broke something. And it's probably something simple. Let's see here, what do you got here? At the moment, the engine layout looks like this. Awake serves when the game is launched initially. Start when the scene gets switched to that scene. Update, kind of obvious. Fixed update with a cap of 60 frames per second. And draw. Yep. Nope, that sounds like fairly standard stuff I've seen in other engines. That all seems like a good starting point. The trick will be discovering patterns that don't fit that framework and discovering what the patterns are for your custom usage. Maybe if your game is simple, that's simple and that's straightforward enough to use, but nothing is ever free. Start simple. Guess that's working. If we read in the QOI and try to dump it to bitmap, that's probably where it's dying. $357. Oh, interesting. Oh, further interesting. I'll bet. Size, yeah, so here's one thing we got going on here. Read, we rearrange things a bit. Size, decode, size first. Boom. And there we go. Okay, so if we go back to test this thing, make them all live, and oh, it's failing still. That's not very promising. Oh, no, that's fine. $357. Decode. Size, width, height. pixel index, width, height, width times height. Having global variables are very useful. Yep. They are, especially in a game, like there are some types of systems I know where people are like, oh, I don't want to have globals. It's like, yeah, that kind of makes sense. But in a game, like there's so much state that needs to be maintained that passing it around in some cases is just a big waste of time. Pixel index blah is not equal to blah. Shoot, what have we broken? What's happening up here? QOI loaded. I think. Width, height, size. So pixel index may not be what I was originally thinking. Nope, that's in there. Why is pixel index equal to my input size? Not my input size, the QOI. Width, height, size. Width, height, width times height, pixel index. Basically this. But pixel index does not indeed match. What have I broken? I have on my Discord, it says I'm playing for more than 215 hours on OpenTTD. Hey, Javest, good afternoon. Merry Christmas to you as well. Merry Christmas. Huh, why is this decoding fewer pixels? Offset. Guess we should check to make sure the offset was correct. After decoding modulus the bytes. That's not gonna work. We didn't finish the bytes. That's part of our problem. 26,280, 26,258. Hmm. Is there a break? There's no break. Do we have consumed all of that? Um, okay. Okay, you have some saving working? Good, good. A simple save usually isn't too hard. It's getting all the little corner cases and details. Scan. Scan. Otherwise, we get the opcode. index, so we look it up and set it. It's a diff. Pretty straightforward. Luma, nothing crazy there. Run. Huh. This is not the output I would expect. Offset size, that's what we're comparing against here. All right, it's the day before Christmas Eve in Sweden, so I'm going to spend a little time with my family. Now we'll be streaming the day after Christmas, before New Year's Eve. Yeah, I'll probably do something Thursday, Friday, probably. I'm definitely not doing anything tomorrow or the day after. Christmas Eve, Christmas Day, I'll take off. But yeah, I'll probably stream something Thursday, Friday. Maybe we'll do like our Emacs stream or something. Something low key, low stress. Oh, because we subtract the header and the footer, which is 8 bytes and 14 bytes, so 22 bytes. $22 bytes, 78, 60, 58, yeah. Okay, so that is the correct number of bytes. But we did not decode enough pixels. Why is that? Shoot. All right, nice. Again, Merry Christmas to you and your family. And you too, you have a wonderful Christmas, and we will see you on the flip side. Let's see, setting the current country will be something. Okay, yep. So you have to have a list of countries to choose from. Oh, so let me decode. Okay, let's go back to here. Let's try this one. That's also failing. Segfault, huh? Inside of decode, 268. Pixel count times 4. $268. That is bigger than 260 than our size. How did we get there? Oh, because of that. That's partly it. That worked better. There we go. Now it's working. We just had an extra byte somewhere where we didn't need it. Therefore, that testing is done. All right, make sure one more time that our image is loading. Then we'll go fix the texture loader in theory. All right, window. Decode. Size. We get our payload, we get our size. We do not have to cast anymore. Cast it there. Oh, so this can't be QOI dot. Okay. So when we read a file, basically whenever I return a buffer, it can't be const. Test again. It doesn't look like it's broken. There we go. I'll make sure that the window logo still pops up correctly. So just a little bit of a refactor around QOI. That's our source. Okay, the logo in the corner looks correct. You can't see it, it chops off the title bar in OBS. But it is correct. So let's just put something down here. My wife just made ice cream. She makes some really good ice cream. She's showing me the bucket of ice cream through the window. It looks so good. Okay. QOI minor refactor. Size next to payload. More consistent. Typing throughout. QOI tests. Still pass. Logo for window now shows correctly. One thing I want to do before I check that all in is after I do that, can I delete image dot pixels? Or does that break things? I think window takes a copy of those pixels itself. I don't think it's okay if I delete them. Perfectly normal textures, just like always. Okay, I think that's good. I think we're good. For logo application, now it shows correctly from QOI data. Minor QOI refactor. Window now shows logo from QOI data. Okay, good. Which brings us to texture store. All right, so we say get a texture from this asset. There it is. A new texture from that asset. So image warehouse, get width, get height, get data. This is the problem here. And two, we do the following. There. image width, image height, image or QOI size, size. Okay, then uint 8t image data equals QOI decode our QOI data, given our QOI size, and our image width, and our image height. Image data unbind read. So this call here basically says, here GPU, here's all the data for this texture, which means we no longer need the image data. And in theory, that may just work. So if that fixes it, we only have one real task left to do. Okay, well, issues abound. We'll figure that out. Okay, texture. There we go. All right. Okay, country thing works. Good, good. Nice thing with JSON is it's easy to read. Well, I tend to be a big fan of binary data formats due to size, performance concerns, etc., etc. There's something nice and readable about JSON. It's not complicated. It's easy for the human mind to parse. Did we fix all the texture issues? We did. We did. So cool. Happy day. So this is running with the same amount of image data, compressed to 14% what it used to be. Oh, so good. Yep, we've got image data. Nice. Somewhere along the way, I did embed one more song in marathon mode. So that should be playing. I did that off after hours. It's not a big deal. Yep, there it is. Which means our audio, it's only adding 38 megabytes of data. So good. So good. QOI decoding now happens. They're in texture constructor. Let's go look at texture again. I'm not sure we ever use this one. I'm just curious. If I got rid of that, would that blow up my code? That's like a simple test, right? I don't think anybody's using it. Oh, font. But font is going to give me raw data, so that's fine. Yeah, this is perfect. So this is, yeah, that's owned by the font, so that's actually okay. Perfect. Test complete. We know what it's doing. We know why it's doing it. And our game is back up to functioning. One thing we should do, actually, we should do a clean release build. And what this is going to do is we're going to finally get our frames per second now that we have texture from QOI. I don't expect a significant difference, even though technically there's more work to decode an image. But I think that our startup times will be faster because we're loading less data into RAM. And then we load textures when we need them, which should only happen once. Otherwise, the texture store keeps track of what we've already loaded. So we won't actually retain those textures in memory. So if I go Control-Delete Task Manager, and this build is complete, we should be able to run and see what my running memory footprint looks like. That's really good progress. We're an hour and a half in. And we've got our major task done. The next task is not a big one, but it is important. One last little bit of optimizations we have to do. Okay, so here we go. We're going to run our release build. And our memory, our running memory, is 82 megabytes of memory. Our CPU is 4%, not much. When we load the level, there's a brief spike to 42, 40, almost 3 megabytes of data. 83 megabytes of RAM in for this program. And it's sitting rock solid at 82.7 megabytes, so it's not changing, which is good. We would not want it to change. I tried to type that, but I mistyped it, so that would have actually helped me a lot. Lumpy. So we're seeing around 1,500 lines per second. Ilum. Really? Tummy. Okay, so we're still seeing around 1,400 frames per second. You can watch the replay, it's invalid. Okay, that's not surprising. It shouldn't be a problem. That's okay. In that wait a second. That replay was not created in the development build. Unless that was a practice game. Are we in practice mode? No. The replay should have been fine then. Oh, when you surrender, you don't get a... You do get a... Right? So our replay is being marked as development build, despite the fact that this is not a development build. So maybe that's something we should go fix real quick. Bug replay created during in release build is marked as develop build replay, thus failing validation. We should fix that some other time. But yeah, QOI is done. Let's save that work. There we go. Boom. Not bad. Not bad at all. Do you want to look at the mess of the code it is in the repo? Sure. I don't want to look at other people's repos. I'm not much of a code reviewer, but it is fun to look at other people's projects. If we're in record mode, blah, blah, blah. Validate. One of the things that will fail validation is release. Right after a major minor patch. If release build in global release build is 1. Release build is not equal to 0, and if release equals 0, scan release. So invalidate header. If we're in record mode, dump the header. Which should be release build 1. If release build is not equal to 0, and if release is equal to 0. Then it will fail, blah, blah, blah. We don't really care if it explodes. Okay, so let's see here. Release build equals something. release flag. Let's see here. Global release, file release, or replay. Oh, oops, I didn't want to do that. I have 2 o'clock on my taskbar. I'm just a little bit short of 2 o'clock. It's, yeah, 1:45. But aren't you in Quebec? Shouldn't you be like 5 o'clock on your taskbar? Your time not update? Literally 2 clocks. Oh, 2 clocks. I see. Hey, AK Elements. Welcome aboard. Thanks for the raid. So for those interested, AK is doing some very interesting work on Onyx game engine, Vulkan-based C++. He's got lots of experience in the game industry. Good sort of person. So giving him a shout out so you can follow him if you're interested. He's been working on his graph node stuff. Good stuff. Oh, how was your stream? I didn't have time to poke in before. Usually I poke in for a few minutes while I set up my stream, but didn't have time to today. How's your node graph going? Your render graph? Ah, the replay works now. Interesting. Okay, well, working. Oh, we just finished 1 week of space optimization. Good, good. Got my render graph editor. Nice. Almost done. Most of the passes ported by now. Only the font render pass left. Cool. Yeah, I was shocked at how complicated font rendering can be. I'm using FreeType 2, and there's a lot of stuff in there. I'm not using most of it, but like filtering out what you need, what you don't need. There's a lot of stuff. Cool. Yeah, we just went through a size optimization pass. So let's see here. Let's go back. I was storing audio data as uncompressed PCM, so 16-bit samples, dual channel. So that was running at 111 megabytes. But we got that compressed down to about 1/4 by eliminating one channel. We tested the left versus right channel, and they're almost identical. So we just dropped the right channel. And then instead of 16-bit PCM, we're storing most of our sounds as MULA encoded, so it's 1 byte per sample. It does this clever thing where it basically turns each 16-bit sample into an 8-bit float, which is very cute. But that gives you a logarithmic response. And so that means that we compressed our audio by about 1/4 of its original size. So we're down to 28 megabytes. And that's embedded in our executable. We went from 4 million lines of code to store that data to just 1 million lines of code. And then we also last week did images. So we had 63 megabytes of texture data, and we've got that compressed to 14% of that size, so about 9 megabytes. Which means our whole executable, it used to be 189 megabytes. It's now down to 45 megabytes executable on the desktop. Statically linked, no external dependencies, no data dependencies. That's it. So that was last week. Which is nice. And we're using a QOI encoding, which we just finished plumbing in today. Like last week, we got it where we were putting the QOI data in our executable, but we weren't rendering it out correctly. And we just finished that today right here. And we just ran our test. We were running about 1400 frames per second, and our release size now is 55 megabytes. I added one more song, but our compression rates are pretty good. Cool. Glad to hear it. Nice. I guess technically this is from last week. Okay, so next up, we're embedding our binary data. So let's take a quick look at that. Source font warehouse.cpp. So we're storing our font data like this. This is binary data read straight out of a file. So there's, file header information. There's the different points that define the true type vector, true type font. That's a very interesting little problem all on its own, but this takes up a lot of space. Every byte of data in this file takes up 4 bytes of data here. And as you can see from the font, from the image, from the sound data file, that's 1 million lines of code to embed this kind of stuff for sound. So we need to shrink this so that we use up even less code. Hey, what's up, Wood? How are you going to shrink the string? Well, we did, for starters, the stupidest thing. Every byte is just encoded as an octal. So \digit means it's octally stored. And we won't save anything if we go to hex, because you have to have \x digit. So we won't save any space that way, but what we can do is we're going to go into Tools, Common. And I'd had this sort of stubbed out before, but I took it out because it was getting complicated. But now we can focus on it. Print a binary line. So here we go. No compression, 4 bytes per byte. This is it. We output a \, 3 digits of octal for the byte of data in our file, right? Not the most efficient thing, but we're going to skip over that. And what we're going to start with is we're going to replace visible characters with visible characters. Step 1. So that does that. I guess there we go. So if it's a printable character, we're just going to print the character. We will escape a quote. That should fix some issues for us. We'll also escape backslashes. So those will be 2 bytes per byte instead of 1 byte per byte. And then if it's printable ASCII, boom, done. Otherwise, we'll output this raw one. Does that make sense? But first, let's get a measurement. Source, we're going to word count line star warehouse.cpp. So this is our measurement. So let's record that in our journal. Binary encoding compression before. Oh, come on. You can see that the shader is not binary, it's text, but image, font, and sound warehouses are. Okay, so this is our before. We'll see what the after looks like. If we go back to common, build, target equals. Actually, let's just run the whole thing. Clean and debug. This will take a minute. We'll see what it does. Does it matter? I assume compress embedded binary source only matters for compile speed, which is minimal. Yes, it doesn't matter too much for compile speed. It matters for me opening the file to read into it. So, for example, this is one of the things that Emacs doesn't do very well, or at least this build. It doesn't do large files very well. So it'll lag out pretty bad if you have a million lines of data. If I can shrink that down even some, that helps the Emacs. So if I have to look into the actual CPP file, I can inspect it better. I don't know that it would really help the compile speed much. The only thing that would change really is the tokenization time, which is not the biggest part of a compile. The biggest part of any compile is the linking. So, plus I'm just curious, like how much does being a little bit smart about your binary embedding, how much does that actually save? I don't know. Let's measure it. This is pretty straightforward. We'll do a few other characters as well. So up here, that did not do what I thought it was going to do. Oh, we're in source. Well, dadgum. Okay. I wasn't in the directory I thought I was in. We need to re-embed all of our data. Okay, embed PNGs dies now. Oh, that's probably true actually. Tools, embed PNGs, 160. Let's see here, char star data, uint8. You don't have to cast that anymore. We've sort of been standardizing some of our size stuff. uint8 right bin, might not be happy with that. Build target equals. And of course not. If we change right bin, almost there. encode. There we go. Let's see what else we wrote. No, that's not what I wanted. Debug. All right. Does the font library have unnecessary glyphs? Would be interesting if you can trip them out if they were. There are. Yes, there are unnecessary glyphs in some of my fonts, 100%, but fonts is not where my usage is really happening. So let's go back up to here. If you look at our embedded data, our shaders are taking up, 11 kilobytes. Our fonts are taking up 1/4 of a megabyte. It's all audio and images. I'm not actually concerned with compressing my fonts right now. It's not enough to worry about. Our font file size is only 10,000 lines for a bunch of fonts, so I'm not actually worried about fonts right now. That is a good question. Yeah, I'm not actually using that many fonts. Fonts aren't that big. Okay, we're getting closer. Oh, for Pete's sake. Okay, tools, embed, fonts. So this is like the last real coding task. Data, uint 8t. Okay, we got further. Embed fonts. So read file. We'll just cast it. I don't think it matters. Yeah, too small to worry about. Yep. Oh, yeah, we shrunk our executable from almost 200 megabytes to like 50. So we're in pretty good shape. Embed fonts is doing weird things. Convert char star to char star star. Oh, right. An address of a pointer. Then we'll look at some other special characters. Again, I'm happy to trade 2 bytes for 4 bytes if there's no loss. So embed wave files. Similar sort of issues. Right bin. Our compressed data. Where do we declare that? Let's see. Yeah, it's already the right type now. Oh, good. Now we're getting it. So yeah, using QOI, we're getting 14% of the size of the total raw data, right? So here's our sounds. We're compressing it by about 25% of the total sound. So that's not too shabby. We might do something more aggressive later, but I'm not going to do it in this release. I'm trying to get the last piece of coding done. Where's my image? Image embedding. If we just had the raw image data, it would be 63 megabytes of pixel data, 4 bytes per pixel. PNG is very aggressive but very complicated. It compresses that, so the actual file sizes are 7.5 megabytes. We get it compressed down to about 10 megabytes, 10.5 megabytes, which is, you know, less than a quarter of this. It's a sixth the size of the raw image data. We're pretty happy with that. Okay, it is complaining about some symbols here. Well, that's unfortunate. Why is it getting trigraphs? I don't know what trigraphs is in this context. Ah, shoot. A trigraph is a 3-character sequence that represents a single character. Why would I want that? If it starts with double question mark? That seems really stupid. Why would I use... question mark equals define. I don't want trigraphs. This is a lot of warnings. Why would I want this? So let's take a look first. Word count lines on things that are warehouses. So already our sound warehouse, 2 million. These should not be bigger than they used to be. Who's outputting trigraphs? Look at font. Ref. See, some of this makes sense. Random letters M. Is it only in the sound warehouse we get this? Source. I don't want to look in the sound warehouse. It's big. We'll give it a minute. See what happens. Yeah, unfortunately, Emacs is not real good with big files. And I'm not even, not that 100 megabytes is that big of a file. It should not struggle this hard. One of the downsides. Modern computers not being used efficiently. Okay, sound warehouse. What trigraphs is it talking about? I don't want it to acknowledge trigraphs even exist. Oops. That's part of our problem, sort of. I want to say no, let's see here. Go to my make file. Let's see here, basic flags. W-no trigraphs. Maybe that will speed things up. It doesn't print out a whole bunch of trigraph warnings. So the data's been embedded. There we go. So we saved 20,000 lines of data there. From this one, 141 to, hey, we're under 100,000. That's good savings. Like I said, I'm not sure how much these text replacements are going to change anything. Probably not much, if any. But maybe this is not going to take as long to load. It's only 108 megabytes now. That's better. Hey, look at that. That looks like there's some better data in there. Okay. So back to common. We also have this block. So if we do this, we have special characters outside of the printable range, right? So if you get a new line character, why don't I just put \n in, and that's 2 bytes instead of 4 bytes. Same thing, a space, I can use a space, I can use a tab. I haven't decided if I want to do this or this. Carriage return, 0 byte, but it causes string problems. So I can't use that just yet. Otherwise, we go with this one. So let's see how that all comes out. And send to warehouse doesn't take very long anymore. That's much faster. So our whole executable is maybe 50 megabytes. And it's almost entirely binary data that we've had to embed. Not almost entirely. I mean, we can do the math. It's not too hard. Okay, let's look at our word count now. Image, we lost another 5,000 lines off that one. In our sound warehouse, another 5,000 lines off that one. Okay, so it saves us some room. We went from this one. Skip that one as a bad run. To here. To here. I think this is probably our final answer. Shader warehouse never changed. And that's to be expected because it's storing raw text. But the result is that we had this many lines out of this many lines. There we go. We saved 28%. So we've knocked off 28%. We saved 500,000 lines of code that way. Most of it in the sound warehouse and image warehouse, which makes sense. 141, yeah. Saved this many lines. Saved this many percent. There we go. Saving 500,000 lines is not too bad. Gonna try a program for making background music. Nice, nice. And that's basically it. For our release size, let's see here. Clean release. We're gonna run the full build. Oh, I think after a mere 2.5 hours, we have completed development on the game. Is that true? So our final executable size, barring any art we need to add or music we need to add later, we're basically done. Okay, so let's check this out. Source builds release. Source builds release. Six. What did we record for week 26? 45, yeah. So we've added a little bit here and there. That's it. 55 megabytes is our whole program and data. If we go to run it, uh-oh, it's broken. We did break it. Shoot. I guess we don't get to save 50,000 lines of code or whatever it was. Some of it worked. What is this other stuff happening here? Alignment issues. Not every texture, but some of them. Huh. Interesting. I wonder where the bug is then. Otherwise, if our byte is new line, if it's a space, if it's a tab, if it's a carriage return. What's going on here? Copy, paste. What if we get rid of this piece? The audio did not sound wrong. Well, shoot. The audio sounded fine. Why are the textures off? Still off. I don't think we changed anything. So maybe it's not the size problem. I'm out of hot water. Shoot. Embed PNGs. Luckily, this is all saved in the last commit when it was working. So close, so close. Hmm. Okay. So it doesn't have anything to do with our current round of stuff. Very interesting. So I think we can put this back the way it was. We've got an error somewhere else. Hmm. I really don't want to see that div. I want to see. Oh, wow, is this Java? Well, Ling Ling, no, this is not Java. I don't do Java unless I get paid a lot. I don't like Java. C++. Mostly C. C with a little bit of C++ on top. Public static void main string arts. How you doing? I'm doing good. I'm doing good. We had this whole thing working not too long ago, and now it's doing something weird to me. So if we do git stash, we make a release build from what used to be in our. Okay, that fails. Hmm. So we made changes somewhere. This was working. And then it wasn't. Embed PNGs, line 160. Const char star data. Oh, I guess we should. We should reload this buffer. So there it is, charge star. I agree that's wrong. Invalid conversion from width height to compressed. I do agree with that as well. So this should be uint. Well, this must be the null difference. Getting my rear kicked a bit by some math, but I'll sleep over it tonight and tomorrow go back with a fresh head. Yep, I used to solve all kinds of problems in my sleep. Exams January 13th. You have time, yeah, plenty of time. What's your math problems? What math class are you in? QR decomposition algorithms. Okay, nothing too difficult, but I'm fairly sure there's errors in my school book. That does happen from time to time. Matrix linear algebra, yeah. Get diff image warehouse is gonna blow up. So I want to do a get restore image warehouse. Look at the diff. Embed PNGs is really the only thing that we changed. So we went from that to that, and we didn't move anything. Data and error to data, which we no longer have to cast. With that filing, that's all fine. We changed that type. Oh, but we did not move this thing. Process data. Data width, height. Oh, electronics. I'm not gonna lie, electronics really doesn't interest me. Weird for a computer guy, I guess, but it's not my cup of tea. Yeah, I'm not that interested in electronics either, mostly. Except in the furtherance of like an actual project, I guess. Width, height, size, compressed size. Encode. I don't use size here. I think that's okay. Return. That looks fine. Then wave files. Oh. So what's happening to my image data? Make release, make build, target equals test QOI. like I'm interested in what my code causes the underlying machine to do. I don't think that's the same thing. Okay, those are running. It look about right. Then PNGs is doing something very strange. About 16%. I feel like that's changed. That used to be closer to 14%, I thought. Why? It's many bytes compressed. Okay, we load a 32-bit PNG file, easy enough. Data, width, height, file name. We get the file size. Here's our compressed size. Here's our size before we compress. We pass in the contents of size. Process data. Right out of binary. QOI encode. Data, width, height. I think there's anything that I've changed in the QOI code. I don't see any changes to QOI happening here. Rebuild everything in debug mode. Sorry, I will say a buddy of mine saved me. He had this class last year, gave me access to his lab results, which helped me improve my report for the better. Absolute G, yes. Sometimes you just have to know what the teacher is trying to ask and what they want. And it makes a huge difference. Oh. But you can't cheat yourself of learning experiences either. The difference between understanding a prompt and what the requirements are and being lazy is a bit of a difference. If you're using the other person's lab to construct your results, that's different than trying to learn. But I am assuming that's not what you did. Problems are fine. MATLAB makes me sad. Yeah, MATLAB was designed for different people, I think. Digital signal processing, it's very powerful, and if you don't want to know much about programming, That's what a lot of electrical engineers will use in their DSP, digital signal processing types of things, or like circuit simulations. They'll use the SPICE libraries for that sort of thing. But yeah, overall, I'm not a huge fan of MATLAB either. I think it just has a whole bunch of built-in math that's been reasonably optimized. So we just did a debug build. And yeah, my compression is not what I would expect. We had that down around 9 megabytes. So what changed? What changed? Why is that compression ratio off? I assume that's what the problem is. Git show, which will only make me sad. QOI. This was all working. Texture, that was working. Oh, what happened? QOI. I didn't add any image data. What is QOI doing to me then? Not robbing his results. Yep, good, good. Exam period does suck though. Basically no time for coding. Yep. No, I always made sure I took very project-heavy classes where you had to make code that works to pass. I thought that was much more valuable than exams, but you still had to take exams when, like you said, during exam week, you really don't have time to work on real projects anymore. For a while. What changed? Yeah, we did that. So if we run it, the sounds don't sound bad. Yeah, the sounds don't sound terrible. And not all the images either. But not all the same images from the same file, which is a little bit bizarre. So the background looks okay. This is the chalkboard, the bookshelf, the table or the books? I can't quite tell. Must be the books themselves. Huh. So what happened to my textures between one run and the next run? Hum. What is happening to my textures here? This was working at this point. What did I break? What did I break? Sound seems fine, yeah. Exam period actually takes 7 weeks. Yuck. Yuck. Few projects we did get to code were in group. Most of those experiences were horrible. They always are. You got Schrodinger's textures. I bet if we all close our eyes, they're there. The textures are there. But what did I break? There's... It was all working. We stash everything. On... Actually, let's just do the image warehouse. Put that back the way it was. We're not going to re-embed our stuff. We're just going to take that last known image warehouse data. Don't want to use trigraphs. I don't know why you would ever use trigraphs. So those should all be turned off. Should not be a problem. Very puzzling. I'm trying to think through the chain of events which would cause my image warehouse to change. I think it has to do with embed PNGs. Get show diff of only a single file. Oh, for Pete's sake. Get diff files. want to hold manual. I just want someone to show some examples. If get A, B, not helpful. Let's see. Surely there must be a simpler way. Get diff a single file, not commit. Commit. I want. The changes you staged for the next commit relative to the named commit. You want comparison with the last commit. So if you do not give commit, it defaults to head if head does not exist. Get diff path. So we'll get diff tools embed PNGs. Should be just the one file diff here. Process data. We check this. That should be okay. So is it something in that? We change data to uint8, so we don't have to pass that. We then pass data straight in. Yep. We changed compressed to the right type. Process data. Encode data. What did I change? CD tools bin. That's bizarre. This is very bizarre. Okay. I'm going to take a quick restroom break. We're going to figure out what's wrong with that texture. Just a minute. Be right back. Okay, the mystery. Mystery is why? I changed something because nowadays we go, let's see here, git status, git add everything just for funsies right now. Git diff tools common right binary. Okay, interesting. That's not the problem. That's not what broke things. The sound is still working fine. That's gotta be something I checked into here. Text representation of binary data is somewhat smaller. However, a bug has snuck into the QOI embedding somewhere. Compression is not as good as it was, and visual artifacts abound. I'm taking a break for C-Film's website to implement the McFly. Good. McFly, yes. Your Python implemented for math. I saw that. It was pretty. It looks like you have a good start on it. Oh. Is that going to become part of your pipeline for C-Films? Like one of the tools that you use to get and generate data for display? So we're going to test this. cd tools bin / input. Go to embedded PNGs. Compile -k clean build target equals embed PNGs. Rebuild it all from scratch. Okay, cd tools bin / embed PNGs.exe. Come back up. Yeah, this compression is not what I would expect. These values all look familiar. This should be like 9 point something. These numbers are no longer printing out correctly, which may be part of the problem. All right, content of size equals that number. Process data. We don't use size. Width, height. This doesn't matter anymore. Size. Why don't we just do this with size? Then we're not going to do anything there. Contents of size, right bin. File key, index, compressed data, and the size. Unit 32T raw size equals 4 times width times height. Raw size. Raw size. Currently McFly is a separate project. What do you think of semicolons in coding languages? What do I think of them? It doesn't bother me. Like, most of the time, syntax your brain adapts to and stops seeing it, and the compiler catches it pretty easily, so it's not like a big cognitive load for me to be like, oh, I missed one, and then it'll tell me where I missed it, so I just put it in. I do wonder if a good, like, it makes it simple for the human brain to parse out the sentences, especially if you're putting things on the same line. It's like, oh, here's 3 things that have to happen. I can see the semicolons. Your brain separates those sentences out. There are languages that don't meet it, but I don't know what you sacrifice in cognitive load and parsing. Like Python, I can't put multiple statements on the same line because there are no semicolons. And I don't know how I feel about that. It forces more verticality, which, is that a good thing or a bad thing? I don't know. Okay. Let me think. Why is this not 9? Why is this 10? For me, the syntax that I want is at a different level than, do you want semicolons or not? I imagine in a lot of cases, you can get rid of the semicolons and not blow up your grammar. Like, it's a convenient way to break up your grammar. But I bet most modern languages probably don't need the semicolons in a lot of cases. Like I said, unless you're building multiple statements on a single line. What happened to my image compression? Compressed data is not what it once was. That compression ratio was, we were down to 9 and change. Let's see here. Git view log the change history of a file. Git log -p. Source QOI.cpp. Okay, wow. Switch commit. We removed this. Can diff. Can luma. Is this our latest thing? Do we just need to go back to this? Or to the one before it, rather? Go back to this one, maybe? Check out single file at commit. Let's see here. Git checkout commit number path to messed up file. QOI.cpp. Let's see. Undefined reference to QOI encode. Probably because I need to get the HPP as well. Maybe we just roll back a little bit and call it good. Invalid conversion from things to stuff. Embed PNGs. Date T star. Let's see here. Let's see here. Okay. Sorry, just reading through something real quick. Okay. Do I undo the changes to common as well? Okay. Invalid conversion. We had all the right secret sauce at one point. Encode. From to I'm getting confused by this. Whatever it's doing. Encode is taking raw. We refactored all of this. Const char star raw data, raw image data. Oh, because of this. Okay. Uint 8t pointer. Okay, that at least worked. Run it. We get our 9% compression back. There's our 9% compression back. Or our 9 megabyte compressed value. We refactored the QOI stuff. And I think it was for the better. So why don't we do this? Let's see here. Let's run it. File save. Let's save this if it works. File tidy debug build. That shouldn't be too bad. Oh, let's see. I want an easy way to run more than one math equation at one time. I want it to be about to calculate 3 plus 6 and 3 times 6 as two different equations. Should this be a semicolon or on two different lines or both? So if it's the easiest thing is one statement per line. If you want to run multiple statements per line, you need some way to separate them. And you can do that a few different ways. One is the semicolons. Like you can have semicolon as an optional element. And if it's there, it treats that as one statement. So you can split your line on semicolons and run them each. But then it would be an optional thing, maybe. Or two, you actually create a grammar. And version, okay. Yeah, everything's a little bit out of whack here. If you use a grammar, you can do things like you compute out as much as you can. You just keep consuming until you complete, until you can't add the next symbol into the current expression, and then you're just done. And that's an expression. Then you start the next thing. I don't know how good that would be. There are some cases where it's fairly obvious, like it's an assignment operator. But other cases where it may not be as obvious what the expression start-stop is. So, but that's if you want to go down the grammarful route, right? So then you're writing a recursive descent parser or something similar. Which one is easier to implement? The easiest thing to implement is one expression per line. The next easiest one would be if you want multiple statements per line, then you have an optional semicolon that you split on. That's probably the second, one of the easier options for you. Undefined reference to in texture. QOI is there. It's built. It's linked. Window. Okay. We will fix this. Texture. I currently use tokens. Right, so if you take, but you're doing it based on user input. So if they hit enter, you take that line, and then you split on semicolon, and you get two chunks maybe, or maybe one chunk, right? And then you feed each chunk of the split into your evaluation. That's probably the easiest way. Generate things one character at a time. Okay. Oh wait, were you using? Oh, okay. Then that is a little trickier then. char star. Decode. We had this fixed at one point. Decode. Oh, because of this. That's right. That should fix that one. Which then breaks that. That's okay. So in theory, this should run without weird texture issues. Okay, so we're back to that point. So we saved this work. Minor rollback of QOI updates. This makes the textures show up right, but I don't like it. Really save our place here, right? It is being developed in Python. Yeah. And if I, okay. Generate one thing, so one character at a time. So if you see a semicolon, then you just stop there and say, this is the end of a statement, and you run it. If you hit the end of the line, then you're at the end of an expression and you run that. Does that make sense? I think adding a semicolon is an optional thing. Wouldn't be too bad in your language right now. But if you want to go down the full like grammar or recursive descent parser, it can get a little bit hairy. It's not too bad though. Like, let's see here. Can I find a reasonable example? That parser. Oh, maybe something like this. Let's see. Dun, 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 dun. So pet parser basically says you take one of your tokens off the stream, and you can look at what else came before it. So if you see one, well, you don't know what to do with the one, so you put it on the list, and then you see a plus, and you're like, oh, well, I need a thing before and after the plus to do the thing, so I'm going to put the plus on the list. And then you see a 2, and the 2 says, oh, well, the previous thing was a plus, and the thing before that is valid for plus, so we're going to take those and assemble them into a structure where plus has children of 1 and 2, right? And you can recursively do this. So when they see, so when you take that 1 plus 2 and you turn it into, well, maybe I need a scratch buffer. Scratch buffer. Let's take the example of 1 plus 2 times 3. What it's going to do is it's going to say, here's a 1. I'm going to put the 1 onto a special list. And I don't know what to do with that, so I'm going to advance. I'm going to move over here. I have a plus, but plus takes 2 things, so I'm going to put that on the list. But it's not complete because I need something on the right. So I'm going to move forward to the 2, and it puts it on the 2, and it says, can I reduce this? Do I know what to do with this? And it says, well, you have something before plus, you have something after plus. So we can turn that into the following. It collapses it down to a list of plus and its children 1 and 2, right? And now there's only one thing on this list. So it collapsed 3 things into one thing, which was plus, and maybe, yeah, I don't know. There's a bunch of ways you could implement it. So you advance to the times, and it says, I don't know what to do with times, so I put it on the list. You advance to the 3, and it says, oh, I have a 3 now. Now it can collapse it. And so it takes this and turns it into something like this, where it says, here's an element, which is a times, and the first thing is this thing, a sub-expression, and then the last thing is the 3. So it takes what's in the middle of a binary operation and says what's on the left and right and puts it as the parent of those two things. So now you have operator precedence and all sorts of things that come of this recursive descent. As you move forward, if you see an operator, you say, what's the next thing? Now make it a child of this and the previous thing for binary operators. So it's something along these lines. Does that make sense? So at the end, all you should have when you get your evaluation expression is one thing in this list. And that one thing is a multiply, which contains things inside of it, like this expression and a constant 3. So it says, well, I have to evaluate this expression, so it can recursively walk its way through this tree. I don't know if that's helping or not. My McFly project is challenging to me. Yes. It's good. You should do challenging things. So let me think if I can give you an idea what this might look like. For token in token stream, right? If it's a binary operator. Oh yeah, we're in Python. If this is a binary operator, eval next to, like, basically put on list token. Elif is literal or something, like you'll have different types of tokens, right? Put on list. And you might do something like if list sub -2, so the second to last item in the list is binary operator. Then we might do the following, where we take left, op, right equals list, slice off the last 3 items. Then we say put on list the sublist op, left, right. This is close to what you want. It's something like this. This is the shape that you're looking for, I think. So keep taking these tokens and making your tree bigger and deeper until you hit the end. And then at the end, like, further note, I guess. You're in Python plus operator precedence check. So just because you have something on the left and the right doesn't mean that that's the next thing you evaluate, right? So in this case, what we actually want is not for this to happen first. We want, this is wrong operator precedence. So when you take the thing on the left and the thing on the right, you have to ask, is this a higher precedence than the current operator? So times should happen before this, but this is going to happen first. It has to evaluate sub-expressions before it gets to this one. So you might have to do a little bit of like rotations of your trees from here. But this is kind of what you're looking for. Put things on the list and then check for patterns off the end of the list and collapse them when you see a pattern you recognize. The McFly code is messy. Yep. The first time you build something, you don't know what you're doing, and so it's an exploration. But once you figure it out, you're like, oh, click. Then you do a little bit of cleanup and you move on. And once you've done enough of that, eventually you're like, okay, I know how the structure of this project works, and then you rewrite it. That's the learning process. You build something 2, 3, 4 times before you really understand it. It is fun building a good language though, or a compiler or anything like that. But yeah, I put a link to parsing overview. It's probably one of the simpler methods to get going, and it teaches you that recursive way of thinking. Okay, now we want to go fix up the QOI to deal with the right data types again. We read a file, uint8, uint8, and our data buffers should be uint8, uint8, no, not that one, this one, 8, uint8. Okay, we're doing that. Uint8. Uint8. Encode. Decode. Let's just see what that looks like. Okay. Now Windows not happy with me because I've been casting things that I no longer have to cast. Same thing with texture. These things okay, now this shouldn't have changed anything. Okay. Yeah, if you want a no-nonsense way to build a precedence, operator, processing, grammar, it's probably prat parsing. That's probably the best balance of get something working and not having to get a PhD in computer science. Okay, so that's all working. Oh wait, that's not all working. We should test it actually working. Which means clean build target equals PNGs. Make sure that that's still working. It might not now. Perfect. We don't have to cast as much. Started the project from an open source Python simple math interpreter project. It was written in OOP. Yep. Pretty common. Data encode uint thing pointer 8 32 size. Why is that not defined? Possibly due to encode. With 8 raw. There we go. Now when we run this from the command line, compression should be about that 9 megabytes. Good. Then we go to texture. Debug, make sure we haven't broken it. We'll do a slightly more incremental thing than I was hoping to have to do. Well, we were really close to just being done. Oh, so nice. Oh. Let that run for a bit. Okay. All right. Okay. 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 Then we should be able to run it, and it should just work. It does. Textures look fine. Okay. Now, this is the part where I want to move size closer to. Do I want to move size? Does it matter? It may not matter. Let's not do that. Let's just not. No changes there. do kind of like the size then width and height. I actually do. Let's do that. It's not actually used in that many places, so I don't think it'll be too bad to hunt all those down. Some of them will be told to me by the compiler itself. We're not reading a file, we're not writing a file. We literally just have encode. I don't even think we have a decode in here. And the next thing is in window. Get the size there, texture. We get the size here. And in theory, nothing has changed. Let's test that theory. Compile, clean, build, target equals NGs. My guess right now is that the other thing okay, undefined reference to encode. Oh, we didn't actually change those orders, did we? QOI.cpp. Right. I just think this makes more sense. Read. If you put the size next to the actual data it's describing, in which case size comes before width and height in almost every case, in which case might as well just do it everywhere. Okay. All right. Oh. When I hit enter, it does not go to a new line. It runs one line of code. Yep. I kind of thought you were doing line-based processing at this point. So you can either split your line on semicolon if you want multiple statements or expressions per line, or you need to do something fancier. Oh, that's not right. I want to do this first. Make sure it's still outputting 9 megabytes of data. No texture QOI image warehouse. Perfect. Okay. And then that should still work. With no weird artifacts. Okay, perfect. All right. Test QOI. So we read QOI read. Oh, let's redo this. QOI read takes the size first. QOI write takes the size first. QOI encode takes the size first. And QOI decode takes the size first. Okay, so this should all work. File. Build target equals test QOI. That should just work. Undefined reference. Const char star. Pardon me. Okay. Test is working as expected. PNG loaded. Running out the QOI. We've loaded this one. I think this is all still kosher. Applied most of QOI refactors. Things still working. All right, last piece. I think I'm going to try to implement the semicolon. Nice. Running multiple expressions per line can be powerful. Okay, our main change that we are most afraid of, I think, was in encoding. We wanted to get rid of our diff and our luma nonsense. Which was that stuff. Okay. Well, something else. We largely steal this code. Uint, no, 8. There we go. B. It has to be the same size for the C wrapped stuff to work. We don't need all these parentheses. We also need these two. We need those sizes to agree for the wrapping to work. Then, if we have 2 less than equal to dr, dr less than equal to 1, and we'll do this much. Plus 2, g plus 2, EB plus 2, because there's a bias introduced there. Else if let's see here. Negative 32 is less than equal to delta green. Delta green less than equal to 31. And negative 8 less than delta red with respect to delta green. DRDG less than equal to 7. Delta blue with respect to green. Parentheses, semicolon. And we can do that, but which is 2 bytes. That should fix most of our issues. If current.alpha equals current dot previous dot alpha. If they're not equal, we have to put all 4 bytes. Which is this one. RGB A. This one we'll put A and we get FFE. All right, if our values are equal, we put them into a run count. If they're not equal, we put it out if there is an active run count. Otherwise, we check if it's a value we've recently hit. If not, we say, are they equal? I guess we could do this. It's equivalent. I think that lines up better. Delete that. Loop. Which I think means this needs to go here. This is the loop. This is the function. Okay. So I think that fixes that. Okay. So where to begin? Where to begin? I guess we start with embed PNGs. red PNGs. Let me run the embed PNGs process and see if we get the compression we should. 9.1. That's even better than before. Okay, let's go to this one. Run the test QOI. It does fail. Why does it fail? These all succeeded. Right, well, here's a question then. Do we have any visual artifacting? Our test QOI should not be wrong. Okay, it is failing. Curiouser and curiouser. Maybe if I look at the implementation. Color at the hash of the current thing is equal to the current thing, we just put hash. Otherwise, okay, so he's doing something like this. Makes sense. Current minus previous, RGB, stuff that into those. R minus G, B minus G, yep. If they're between these things. Otherwise, check for between -8 and that. So, change in green, delta green, red, blue, those things in with their biases. Otherwise, RGB, otherwise RGB A. Color equivalency checking. So why is this not the same? Clean build target equals. And it just fails. Why does it fail? These two numbers are not the same. Which happens at the end of decoding. So why is our decoder failing? Let us simplify everything way down. All I want is to load the PNG and dump it out. It seems to succeed. Question mark. Yeah. Okay. We read in a regular old QOI, it should run and succeed. That runs. It runs. It doesn't necessarily mean it's correct. Looks about right. So what that means is this piece, which is the output of this piece, is failing due to a bad encoding. We're successfully reading in example QOI files. We're successfully writing out a file without failure. But we aren't able to read in the file we wrote out. So I think this will fail. As will this one. Curious. Active projects. Word sleuth. Tools. Three. 14. All right, so let's find. Oh, it's in the desktop. QOI test images. So the test card RGBA is 18 kilobytes. We're outputting 23. It's not very good. Why not? So it's a problem in our encode when we restructured things a little bit. For each pixel, we get the current pixel. If the current equals the previous, we increment. If we're run enough, put this run counter. If it's not equal, then if we had a run, we end the run by running it out. Then we say, do we have a hash of the current thing? We can just tell it to look up that hash. Easy enough. Okay. If the current color and the previous color have the same alpha channel. Otherwise, we put out RGBA. If they are equal, then we write out change in R, change in G, change in B. We check our range. Then we put it out. Otherwise, we check these ranges. DR, DG, DB, DG. Otherwise, we output RGB. Previous equals current. I'm not sure how the logic is different from what I had before. Am I fighting a battle I don't need to fight? That's possible. Very possible. This is so much cleaner than what we had before. I don't like this. Index is 0, diff is 4, luma is 8, run is C, RGB is FE, RGBA is FF. We have the mask. We have the hash. We have the magic number, header size. encoder is wrong, even though I think it's more right now than it ever has been. Let's see here. Oh, good heavens. All right. If they're equal, add to the run. If they're not equal, dump the run. Get an index, check the index, otherwise index this thing. If A equals A from previous and current. Find those, find those. Plus 32 plus 8 plus 2. Interestingly, it's this thing. Oh, I see. I see what it's doing. Never mind. Don't care about that. Encode. Okay, my code looks an awful lot like this guy's code, actually, no? But it's outputting the wrong things. Even though it's more like his code than ever before. Oh. So go through this cycle here. Maybe we have fixed it. Failure. $64, $678. Maybe we just go up and go back the way it was, although I don't like that. Get a lot more RGBAs, less RGBs, index, we get less of, diffs, we get less of, more of. So how do we get more diffs? Lumas. We get quite a lot less, but we do get more runs. Why is this? It's just somewhat puzzling to me. What am I doing in here that's so egregious? We don't take raw data that's not null. We take our width and our height. We start with a default size of 0. We count on a number of pixels. We get a size that's equal to the number of pixels times 4, which is reasonable. We start with color 0, 0, 0, opaque, so black. We start with transparent black in our array, which is fine. We cast our raw data to colors. Run count starts at 0. For each pixel, index equals 0. Pixel index less than pixel count. Go to pixel index. Grab the color. We don't actually have to do all this nonsense too. Pixels at pixel index. There we go. If the current is equal to our previous, we just increment a counter, unless we're full up. Otherwise, looks good. If hash equal end of the run. We get our hash. If current color equals the array value, and we put it. Otherwise, if the alpha channels are the same, put index lookup and what the index lookup, put up delta. So put up that one. Not seeing the logical issue here, but change our behavior drastically over what we had before. Which makes me sad. I don't understand it. My code looks okay. Waffles and syrup. Wave stuff. How's it going? How's it going? What's new? We're trying to figure out what's wrong with my QOI image encoder. It's doing something weird, and I don't know what it is yet. So I have a little test program which reads a PNG, dumps it out as a QOI file, then reads that in. Well, it reads in a reference QOI file. So this is one that came with the QOI documentation. And then we read the one we outputted here, and we can compare. And we're getting wrong information. This is not the number of pixels we expected. We expected this many, not this many. So our QOI encoder is doing something wrong. Anyway, so waffles and syrup, waffles AMD syrup. I'm gonna play waffles and syrup. That's easier. Let me know if you have any questions. We're just trying to get our image data size down, but we're breaking something. Something is broken. Even though my code looks more like the reference implementation than it did this morning, it's just not working. I do not want to look at the image warehouse. I know it's wrong. If source QOI.cpp oops. I like the way I'm trying to do it now, but it's not yielding the right results. QOI, I've got my pixels, I've got the raw, I return the raw, right? Or return the result. The result equals this thing. We return the result. Number of pixels times 4, that's fine. Not seeing the issue here. For each pixel, we get the pixel. The current pixel equals the previous pixel. We increment our run counter. If we overflowed our run counter, we put it in there. Otherwise, if we have a run going, then we dump it. Yep. Get our hash of our color, current color. If it's one we've seen recently, we dump it. Otherwise, let's see. Otherwise, if the alpha channels are equal, we can look at these deltas and put out a diff. Aha! Oh my gosh, I bet that's a problem. DGDB. We need to check that the red, green, and blue channels have a small diff. Oh, Hopefully that's it. That would yield incorrect results. Woof. Okay. Okay. If test QOI works, okay, we're back to running again. Hallelujah. Woo! Run it against both our test images. All right, we're running. Now if we go to embed PNGs, all right, I think that's fixed. Oh my gosh, I can't believe how long we spent to find that typo. Kind of embarrassing, but like these things do happen. Okay, we run it. We see how much our compression is. There we are. That looks similar to what we've had before. 14-ish%. Then we can go to here and rebuild this thing. Image warehouse is getting trigraphs. I could swear we said no trigraphs, please. Base flags, no trigraphs. I said no trigraphs. -W, no trigraphs, right? Oh, debug. My bad. Which probably means that's all wrong. Darn it. Tidy things up and then debug. Okay, it's gonna do a little bit of rebuild here. Trigraphs. What a stupid idea. I wonder if it has to do with why does C have trigraphs? Why does GCC have trigraphs? What is their purpose? Different systems use different dimensions to indicate end of line. Blah blah blah. Digraphs and trigraphs. Sequence of 2 or 3 letters that are treated by programming languages as single characters. Why? Why? C programming is a subset of ASCII character set, includes 9 characters which lie outside the ISO 646 invariant character set. Implementations. Jeez. Yeah. Oh well. Looks like the build is about done, and our graphs. /source builds debug. And our textures are not ruined. Perfect. We've got it. Oh my gosh. I can't believe it was a copy paste error of 1 character. This all looks about right. Last QOI update complete and working. There we go. Done. Now, where does that leave us? Oh, journal. Oops. QOI. There was some faffing about QOI update, found the copy paste typo, and the refactor has all been put back in and is fully tested and functional. Oh, thank goodness. That's it. So now, word count here, cd source, word count -l of star warehouse.cpp. This is our final answer. We can put this one back on top. So we've got our font warehouse size shrunk down. Wait a minute. This is not the shrunk down size. Font image warehouse is smaller. Sound warehouse is considerably smaller. Why did font not get shrunk? Oh, I bet I know why. Okay. Yeah, incorrect. So what we need to do then is a pull up, clean, rebuild. So that all of our resources are rerun through everything. That's not right. Now we'll redo all of our image and sound and font data, everything, all of it. 430. Not bad, other than a stupid copy paste error, we made good time. Our executable, we should see our sizes and see how much of our executable is data versus code, which is kind of an interesting little exercise. Yeah, our build times have definitely improved a lot over the last week. Almost there. So our debug run runs. Here's our final data size for our whole run. So we now know how many megabytes is just plain data. Then clean release build. Let's do a full release build. And while that's running, I'm going to take a quick restroom break. While the build runs. Okay, I'm back, and looks like the build completed correctly. So we should be able to run the release. Running great. Running codes. Laced Rhino crowd lines. Perfect. Everything's looking good. We're running 1600 frames per second on a granted very decent machine. Okay, we're up and running. We're good to go. The replay did not validate, which is a little interesting. We'll have to take a look at that again. Okay, but our executable is 55 megabytes. Here's one thing. The other thing word count. Our warehouse data. Take a look at this now. After all of our cleanup. That's not what I wanted. Font, image, sound. Five, 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 4. 1770 976. All right, so we've saved 54, 54, 22 lines. Over, yeah, saved 500,000 lines of code. Not bad. The other thing we wanted to look at is our executable size, which we did. Our FPS was around 1600. So our release size let's just run this in Python. Over 10, 24 times 10, 24. So this is my size of executable in bytes, in megabytes. And then we subtract out our data of megabytes. So exe size equals this previous thing. Yep. Exe size minus 0.011 for the shaders, 0.285. That's 37.678 plus 9 megabytes 54 of image data. Means that our actual release executable, our executable code size is 5.6 megabytes. And executable size, just the code data size. That's all we really need then is this number. 228. Let me get this phone call, just a moment. Okay. The semicolon or white space works for numbers, but only white space works for strings. Interesting. Okay. Sounds like there's some corner cases you need to work through. Anyways, so this is an interesting finding. Literally, our executable and all of the statically linked libraries are less than 6 megabytes. Almost everything in our executable is this binary data. That's crazy. Just crazy. Mosquito. Okay, so that brings us to the end of an era. We have no more string tasks to do. If I get new art, I will integrate new art. It's not code. If I get new songs, I will integrate new songs. That's not code. I have to do some like word library checking, but that's not code. And I have to add a couple more image sprite animations, which is not code. So we're done coding the game. Everything with the game is done except I need to make a web page for it. I need to make a trailer video, and I need to update my screenshots with the latest art. And then I can post the whole thing, which means we're done on the stream side. Everything else is done. Website, trailer, any art or music updates to be done, but no more code. We're done with code. So I think we're done with the stream on this series. We will, at least on the word sleuth side. So Thursday we'll do something different. Maybe we'll rebuild my Emacs from scratch or something like that. Something low key, I think. But yeah, we've basically done it. The game is essentially complete for all intents and purposes. That feels good. That feels good. So I think even though it's a little early, we might end up the stream early. It is Christmas, so it's a holiday, all of that jazz. I need to do a lot of preparation still before tomorrow. But thank you for joining me on this journey. I will definitely keep you posted on the off-stream updates and let you know when it releases on Steam. But yeah, that's a done game. You've watched me. Well, let's see here. Where are we at? Get status should have nothing in it. Look at our last commit. Let's put that in source documentation metrics input weekly. Let's update my records real quick. Week 26, which will be week 27, 12, ending the, or starting the 23rd. This hash. We've been going for what, 4 or 5 hours, give or take. We'll call it a round number for now. Let me grab the other numbers I need for this calculation. We need 552. 54, 308, 07, 6, 01, 28, and 547, 14. That's it. That's how much time we spent last week working on it. This is how much time we'll spend roughly today working on it. Okay, let's go take a look at our code metrics. Update our weekly analysis. A couple of commits, comparing a couple of commits, probably 2 comparisons or so. This is probably now wrong. Clear our weekly. We probably need to rerun the whole thing. Reset our weekly. Probably need to reset our monthly. This is going to take a minute. What it's doing is pulling down each commit from the end of each week and computing a bunch of statistics about each one. So this could take a while. Some of these commits get quite large, and there's 20, 25, 26 of these. If we look at this, we've got 27 weeks. We've been working on this for 27 weeks. That's half a year. Half a year. It took us half a year to do this. Granted, we were only doing 4 days a week, and we do about 6 hours a day. Most of the time. So that's a 24-hour work week, 6 months for one developer. I don't think that's that bad. Like I said, some of these, especially ones that have a lot of image or sound data, these can take a while. Hopefully it's not just stuck somewhere. There's one thing I'm curious about is why Why do we spend so much time talking about performance and programmer time when we never keep track of what that is? I'm at least measuring something. And I have the hook set so I can measure other things if I care to. I just don't know what that would necessarily look like. We have the commit for the end of each week. We have how much time I've spent doing different things. It's all clearly marked and labeled. Okay. Now we're getting there. Some of these diffs take a while, but we will be able to see a summary of all this stuff. Some big ones, like I said, with sound. Oof, my computer's really grinding on a couple of these diffs. Oof. It's really grinding my computer here. Oh, that's grinding away. I did try to do some changes to the QOI format for myself. I thought if I gave myself 4-bit opcodes, then we could have some different operations. It actually turns out this guy who invented the QOI found like a great balance of simplicity and compression and speed. Whatever I added got closer and closer to the size he got, but never quite. And it was never as fast because of the additional opcodes it has to check against. And it wasn't a lot slower, and the compression wasn't that much less most of the time. But it was just he has the right mix. So it's too bad. Okay, we did it. Now we can see the summary of our weekly progress. That doesn't take long. Here we are. We're up around, oh nice, 31,000 lines of code. That's about where we're ending. We lost a few, that's fine. Pretty good, 31,000 lines of code. Touching about, well, I need to update all this into something, but yeah, we've been grinding away at this 31,000 lines of code. Pretty good. I think we're going to call it there for today. Thanks for joining. You have a wonderful evening, a wonderful Christmas. We'll see you on Thursday. And yeah, you have a good one. And I'll see you on the flip side. Bye-bye.